Okay, this is our review guide for Chapter 12 for matrices. So I'm going to move through it pretty quickly. If you have any questions about anything, please don't hesitate to email me. Okay, first and foremost, what is the element A sub 2, 3 in a matrix A, in matrix A? Okay, so in our matrix here, we got to remember that this is telling us where the element is. And always with matrices, we're talking about rows, and that is not what I wanted. Rows by columns. So this is giving us the information of the row and the column that we're in. So we're in row 2 and column 1, and the intersection of that row and column is 4. So the answer to that is 4. All right, for the next one, it's asking us row 1 and column 2. And the intersection of row 1, column 2 is 5. So the answer to this problem would be 5. And I got to change that. All right, so 5. All right, simplify. To simplify, add and subtract matrices, we have to have the same dimensions. So we can see that this is 2 rows, 3 columns. That's a 2 by 3 and a 2 by 3. So we're going to combine corresponding elements. So negative 2 minus negative 1 is negative 1. 2 minus 3 is negative 1. 0 minus negative 9 is 9. Negative 5 minus a negative 2 is negative 5 plus 2, which is negative 3. 5 minus 4 is 1, and 9 minus 7 is 2. Okay, next we have another one, same kind of thing. So let's go combine our corresponding elements. Negative 2 minus negative 1 is negative 1. 2 minus 3 is negative 1. Okay, well, that was the craziest thing. Oh my goodness, sorry about that. 0 minus 9 is negative 9. Very similar. Negative 5 minus a negative 4 is negative 1. 9 minus 4 is 5, and 9 minus 7 is 2. So, make sure that you remember when we add and subtract matrices that we have to have the same dimensions. And our dimensions, what happened to that up there? Our dimensions are always rows by columns. That doesn't look like the word columns. Columns. There we go. Okay. Now we are find the value of each variable. So what do you remember here? You got to remember that if two matrices are equal, then their corresponding elements are equal. So 2x plus 4 has to equal 10. So you need to, and I did talk about this, y'all, when you have problems like number 3 and 4 where you're just adding and subtracting, I'm okay if you don't show me any work, if that's the only thing you show me. But when you get down to something like this, you need to write an equation. And from there, I'm okay if you tell me what the answer is if you don't want to show me any more work than that. But you at least need to show me a setup equation if it's more than just adding and subtracting. Okay, so I'm going to subtract 4 from both sides. 2x equals 6, and that means that x equals 3. All right, so that's one of them, which I'm going to, you know what, I'm going to erase that because it won't fit. Let's try this. 2x plus 4 equals 10. 2x equals, oh, go away. Oh, wait, there we go. 2x equals 6, and x equals 3. Okay, then we have a y, and the y is right here. So negative 4y equals 16, and y equals negative 4. Okay, this is the one problem, y'all, on the test when you have this, that, let's finish that, 10 equals 2z, and so divide both sides by 2, so z equals 5. This is the one problem where you actually don't have an answer that looks like a matrix or an ordered pair. You just tell me what is the value of each of those elements. Okay? I need to pause 1 second. I'll be right back. Lost my pauser. Okay, I'm back. All right, so this next one, we have a matrix plus a matrix equals another matrix, a little bit different from this one because there's an operation in between them, but you're still dealing with the corresponding elements. So that means that x plus -4 equals -3. So x plus -4 equals -3. Of course, we would add 4 to both sides, so x equals 1. Okay, and then we have a y. There's that y is in the second row, first column. So 6, same corresponding position. 6 plus y has to equal 9. So I have 6 plus y equals 9. And then I subtract 6, so y is equal to 3. Okay, what else we got there? Yikes. Not supposed to do that. Then we have a z. So that's, if you think it's hard, but that's another element that you got to figure out. So 7, I don't know why that's showing up. 7 plus z has to equal 5. 7 plus z equals 5. Subtract 7, so z equals -2. So again, this is where what are you going to put in the blank is what those variables are that are missing in the matrix. Okay, next. We have combining matrices where there is a scalar involved. So this is more than just simple adding and subtracting like we had in number 3 and number 4. So when you do this, I need to see some kind of work. And I'm okay with, if I'm going to multiply everything by -4, then I'm going to just go write it on top of it. So -4 times -5, -4 times -1, -4 times -5, -4 times 4, and -4 times 8. So I have all those numbers, and now I need to add them with matrix B. So what do I get here? 12 plus 7 is 19. 20 plus -2 is 18. 4 plus -5 is -1. 20 plus -7 is 13. -16 plus -1 is -17, and -32 plus -8 is -40. Squeeze that in there. Okay. Same thing with number 8. Just making sure we don't have anything different. It's subtraction, and we've talked about that. However, if you want to distribute a -7 or you want to distribute +7, as I mentioned before, I like to do a -7, and then I just add them. So I'm going to say -7 every time I multiply these. -7 times 7, -7 times 4, -7 times, I don't know why it does that. Oh, look, it went away. -7 times 1, same thing. -7 times -4, and same thing again. So now all I have to do is add these. And what's that going to give me? -6 plus -49 is -55. 7 plus -28 is -21. -7 plus -7 is -14. -2 plus -7 is -9. 6 plus 28 is 34, and 8 plus 28 is 36. And there you have it. That's multiplying with a scalar and then adding and subtracting. Okay? Solve the matrix equation. Okay? So, similar to what I did up there, I'm going to go ahead and distribute this 5 through there. And I've talked about several ways of doing it. This is how I'm going to do it on the video. If you need help with that, please come see me before school, and we can talk about other methods that you can use to solve this equation, because it should not be hard for you. All right, 5 times 2 is 10. 5 times -8 is -40. 5 times -4 is -20, and 5 times 2 is 10. So I have x plus this matrix equals that. And most people know, what do I have to do is I have to take this matrix minus that. And this is when I talked about in class, x plus 5, stop it. 5 times a matrix is equal to another matrix if I assign this to A and this to B. And how would that would be equal to subtracting 5A, so it would be B minus 5A. So I'm taking this one and subtracting that number. So that means that X, my dimensions aren't going to change. 4 minus 10. Negative 6 minus negative 40. 2 minus a negative 20. And negative 8 minus 10. And that's what you get. So that is our matrix. All right. Now, this one is a little different because there's a number in front of the X, but you can do it the same way. If I distribute that 5, I'm going to have 5 times 2 is 10, 5 times 8, 5 times negative 4, and 5 times 2, which is 10, which is exactly the same thing as that over there. And so since it's the same thing, I'm just going to subtract these two, which I've already done right there. But the difference is this is equal to negative 2 times the matrix, not just the matrix. So I have this same matrix because all the numbers are the same. I didn't realize that. I'll have to change that next year. Negative 20. Nope, that's not what it is. It's positive 22. Right, so put that back. 20. Golly. Shoot me now. 22 and then negative 18. Okay, so we took this matrix and subtracted that matrix to get this whole thing on the other side. So it's equal to negative 2x. Now I have to go divide each of those by negative 2, which is going to tell me that x is equal to negative 6 divided by negative 2, 34 divided by negative 2, 22 divided by negative 2, and negative 18 divided by 2. So that would be your final answer. So maybe that was good because maybe it will help some people that struggled with that be able to do the problem. All right, I'm going to move this. Come here. I want to move this up here because I want to have room to talk about finding the product, okay? So remember, finding the product, y'all, how do you multiply matrices? You multiply rows by columns, okay? And it's not always defined. So you got to pay attention. Again, I need to change these up because these are all the same dimensions. But remember, if I gave you something like, well, let's just do this. Let's go with 0, negative 4 times 3, negative 2. So yes, I'm adding one that I talked about in class so people would know. But the dimensions of this matrix here, that is 1 row and 2 columns. And the dimensions of this one is 2 rows and 1 column. And we've talked about that if those numbers are the same, then it will work. And what will it be in this case? It's going to end up being a 1 by 1. So we do the row times the column. 0 times 3 is 3. 0 times 3 is 0. Negative 4 times negative 2 is 8. So I want you to be prepared on the test that this problem might not be a square matrix. You have plenty of multiplying square matrices later in the test. So remember that that's how you have to do. And if those two inside numbers don't match, what do you write in the blank? Just like you do in the quiz, you're supposed to write not possible. Do not write no solution. We are not solving an equation. Just say not possible or undefined. Either one of those is acceptable. Okay, so continuing on with this. Find our product. These are all square matrices. They're all going to be defined, and the answer is going to be another square matrix. So we're doing first row, first column, which is negative 4 plus 0. Boom. And then we have, I'll do this, maybe this will help people follow. Then I have first row, second column. 1 times negative 6 is negative 6. 0 times 6 is 0, so that's negative 6. Okay? Then I'm going to go to second row, first column. Negative 4 times negative 4 is negative 16. Negative 16 plus 25 is 9. And then the last one would be second row. That's supposed to be an arrow. Second row, second column. You always start at the left of the rows and the top of the columns. So that's negative 24 plus 30, and that, of course, would be 6. So that is our final answer. All right, let's go do another one of these. I want to go with this so you can see as we go do all of the different ones. Okay, so starting off, first row, first column. Negative 20 plus 35 is 15. First row, second column. That's the first row, second column. First row, second column means I use the first row and the second column. 4 times 5 is 20. 7 times 1 is 7. 20 plus 7 is 27. Okay. Second row, first column. Negative 1 times negative 5 is 5. Negative 7 times 5 is negative 35. 5 plus negative 35 is negative 30. And then, that's fine. Let's go with this one. So then negative, second row, second column to get second row, second column. Negative 1 times 5 is negative 5, and negative 7 times 1 is negative 7, and negative 5 plus negative 7 is negative 12. So there we have it. All right, last one of these. And I'm going to do that out again so it's easier for you to look back and check. So let's start with that. So first row, first column. 18 plus 48, 66. Then I'm going to go to first row, second column. 30 plus 42 is 72. Then I'm going to go to second row, first column. Negative 18 and negative 72 give us negative 90. And then second row, second column gives me negative 30 and negative 63, which is, of course, negative 93. All right, so hope you have that down. Please go do IXL if you don't, okay, because it's an important thing. All right, what is the area of the triangle with the vertices as such? Okay, so one thing you need to know is after I wrote this, I decided to put this formula on the test. So you will have this area equals 1/2 the absolute value of, as one of my students said today, det A. So hopefully you know that det A stands for the determinant of A. So if we go try to calculate this problem, okay, so let's go with area equals 1/2. Well, one thing you have to know is you have to know how to set up this matrix A that you're supposed to find the determinant of. So you list these, negative 5, and I'm going to run around, that's great, negative 5, 3, negative 2, 2, and negative 4, 2. Now, if that's all you do, you're going to be in trouble. You have to remember, okay, you can only take the determinant of a square matrix. So when I list those points, I got to make it a square by adding these ones down here. And then we get into that thing of copying this row, negative 2, negative 4, 3, 2, and 2. And now I'm going to come back and calculate, okay, the determinant of a matrix, okay, of our 2x2s and our 3x3s that we have to do by hand is downhill minus uphill products. You have to multiply. So my downhill product, this is a great way to show your work for me on the test, is negative 5 times 2 times 1, which is negative 10. 3 times 1 times negative 4, which is negative 12. I'm adding these products, y'all, okay? And 1 times negative 2 times 2, which is negative 4. So I have negative 10 plus, is it negative 12 or positive 12? It is positive 12, okay? Oh, that's what happened. Let me pause for 1 second, please. No, don't do that. That's not what I wanted. Go away. I wanted this one. I'm back. So this totals, sorry, having one of those days, negative 26. Now my uphill product is going to be negative 4 times 2 times 1, which is negative 8. 2 times 1 times negative 5, which is negative 10. Stop. And then 1 times negative 2 times 3, which is negative 6. And that gives me negative 24. So to finish putting that in, the area is 1/2 the absolute value of downhill minus uphill. So negative 26 times minus negative 24 is negative 2. So our answer is 1 square unit. Okay, let's do that again. So the really key, one of the things to remember about that, what you have to remember is, first of all, you got to remember to add the ones. And then you have to remember that your area can never be negative. So that's what these straight lines are telling you, that you better have a positive answer when you do this problem. Okay, so let's look at the next one. Same deal. So we have area equals 1/2. So what happened, I figured out, y'all, one of them was supposed to be positive, one was negative, but I ended up with a typo there. So they're both negative. But anyway, negative 4, 3, 3, 1, negative 2, negative 2, but I have to have a square matrix, so I put 1s on that last column. And now I'm going to go copy those. Negative 4, 3, negative 2, 3, 1, negative 2. And now let's go calculate. So my downhill product is negative 4 plus negative 6, excuse me, plus negative 6. Which is, of course, negative 16. Okay? Yeah, in case I did that too fast. This is my first downhill. That's negative 4. Negative 4 times 1 times 1 is negative 4. 3 times 1 times negative 2 is negative 6. 1 times 3 times negative 2 is negative 6. That's probably just as fast. Not bad. Okay, uphill. Negative 2 times 1 times 1 is negative 2. Negative 2 times 1 times negative 4 is positive 8. And 1 times 3 times 3 is 9. So this actually gives me 15. And so, to finish that, 1/2, well, whatever. Guess I got a ghost on this thing, y'all. 1/2. Area equals 1/2 the absolute value of the downhill minus the uphill. So that is 1/2 of negative 31, and the absolute value of negative 31 is positive 31. And when you take half of that, you're going to get 15.5 units squared. Okay, turn your study guide over. Does the matrix have an inverse? Well, how do you know if your matrix has an inverse? You have to know what is the determinant. Okay, so as you can see, I'm giving you one of each kind, but you only have one of them on your test, so you don't know which one you'll have, or something like it. All right, determinant. Remember, we just talked about downhill minus uphill. So my downhill product is negative 9. My uphill product is negative 8. Well, that's not 0. If it's 0, the answer is no. So that means I'm going to have an inverse. So so let's answer the question. The question is yes. Does it have an inverse? Yes, it does. What is the inverse? 1 over negative 17 times, this when we switch these two, negative 1 and 9. And I'm running out of room. Negative 4 and negative 2. So we switch this diagonal and we take the opposite sign of these, which we say is negate. Okay, so to simplify that, okay, you don't have to do anything but just multiply it out, which is not very hard. 1 over 17, they're both negative, so it's 1 over 17. 4 over 17 2 over 17 and negative 9 over 17. So that is our inverse, and we're very thankful that we don't have to do anything more with it than that. Okay? All right, go away. All right, back to the next one. So what do we do first? We're trying to find out what the determinant is. Well, it's got some zeros, so good chance it doesn't. But the determinant is downhill, which is 0 minus 0, which equals 0. And that would be, y'all, this is the least amount of work you have to do on that. But if the determinant is 0, then the answer is no, and there is no inverse of that matrix. Okay? On this particular problem, okay, when you see it on your test, it will be there. Are the matrices inverses? So, of course, you have to say yes or no, which y'all say yes. And unfortunately, your worded explanation was not enough. It was not complete. So, really, the easiest way to justify your answer is to multiply A times B. So, I'm going to multiply A times B here. So, negative 3 times negative 7 is 21. 21 and negative 20 give me 1. And then first row, second column, first row, second column. Negative 3 times negative 10 is 30. And negative 30 give me 0. Are we on the right track? I hope y'all said yes. Let's keep going. 2 times negative 7 is negative 14. Negative 7 times negative 2 is positive 14. Negative 14 plus positive 14 is 0. Now, what does that need to be for the answer to be yes? It needs to be a 1. If it's not a 1, the answer is no. But that's your work right there. So, actually, and I should say, this is what we're doing. A times B equals that. So, second row, second column. So I'm doing this times this. So 2 times negative 10, negative 20 plus 21 is 1. So the answer to this is yes. Okay, moving along. Evaluate the determinant. Well, we've just done some of those, so hopefully this is not going to be that challenging. But let's see how we can squeeze this in here, because your teacher was so nice to give you lots of room here. Negative 5, 0, negative 2, 1, 3, and 3. And so my downhill product, I'm going to write it here. Downhill product equals, what is that? 10 times 3 is 30 plus negative 6 plus 0. And my uphill product, I'm going to write it up here. First one is negative 6 times 6, which is negative 36, plus 3 times 3 is 9 times negative 5 is negative 45, plus 0. We love these zeros. Okay, so this one simplifies to negative 81. And this one simplifies to 24. And it's downhill minus uphill. So 24 minus a negative 81 is 24 plus 81, which is, of course, 105. So the determinant of that matrix is 105. All right, we're going to do another one of those. 3, 5, 1, and then 5, 2, and negative 2. All right, so let's do the same thing here and calculate our downhill. So my downhill is 3 times 2 times 4, which is 24. 5 times 1 times 1 is 5. 3 times 5 times negative 2 is negative 30. Okay? And my uphill product is 1 times 2 times 3, which is 6. Negative 2 times 1 times 3 is negative 6. Plus 5 times 4 is 20 times 5 is 100. Well, those cancel each other out. So this is equal to 100. And this one, that's 29. And 29 minus 30 is negative 1. So my downhill minus my uphill is going to give me negative 101. Okay, so those are a lot of fun, but we got to move on to a 2 by 2, which we've done. That's your downhill minus your uphill. Still doing duh. So -7 times -7 is 49 minus a -30. So this is where people mess up on. Determinants are always minus here unless you're adding the products. Okay. 49 minus -30 is 79. So we are good to go. All right, last one of those. Downhill minus uphill. -7 times 4 is -28. 4 times -3 is -12. -28 minus a -12 is -16. Again, y'all, if you have any questions about anything, email me. You can get the time of the video, email me specifically about something, or, just type me up a nice little email. Okay, what is the solution to the matrix? I don't think I'm going to have enough room. So, well, let me see what I can do. I'm going to squeeze it in. I apologize for this. All right, so what do I have here? This is the one where you're going to go and you have to use inverse matrices. I'm going to actually start over here. So, no, I'm not. I'm going to go back over here. So, xy, go away, xy equals the inverse of 12, -3, 16, 4. It's really important that you put this, stop, y'all. Go away. Back to my phone. Put that -1 up there, especially when you do the 3x3s, because people don't put the right thing in their calculator. All right. So the first thing you're going to do is go calculate 12. Oh, righto. Let me tell you something real quick, y'all. That says number 23, but the numbering got a little bit off, so on your problem, it might be number 25. Okay, whatever. Anyway, you got this problem. Make sure you're looking at it. Okay? So, I'm going to do 1 over the determinant, which is 48 minus a -48. Okay? Downhill minus uphill, just like we were doing right up here with 21 and 22. Then, I'm going to do, I have to switch these two, 14 and 12, and switch those two, which is 16 and, no, I don't. 4 and 12. I switch those two, I negate these two. I need a negative in front of that. And then I multiply it. And this is where you'll really be sorry if you're not paying attention. Because I'm telling you, golly, you do not want to distribute this. You want to multiply these two together. So I'm left with 1 over 96. And then I'm going to multiply these. 4 times 3 is -12. -12 plus 12 is 0. Did we do something wrong? No, we're good. Except for, I don't know why I wrote down 3 and 4. So you're probably yelling at me, as y'all do all the time. And that's why. All right, let's go back. It was not supposed to be 3, 4. It's supposed to be 144 and -64. 144 and -64. That's why we have a calculator too. All right, so 4 times 144 plus 3 times -64 gives me 384. First row, first column. 4 times 144 plus 3 times -64. Then -16 times 144 plus 12 times -64 gives me -3072. But we are not scared of these numbers because we have a calculator. Then when I divide both of those numbers by 96, then I get my answer, which is 4, -32. Okay, again, I apologize for that squinchiness. Let's go do the next one. All right, so same setup. All right, it just looks like a big X instead of the XY matrix. It's still a matrix. So I'm going to do, that means that I'm going to have to take the inverse of this matrix. So I put the -1 times 4, and that is not a 4, times 4, 9. Okay, now, first thing I do, 1 over the determinant. What's 2 times 3? 6 minus, that is 6, which is 0. All right, and 1 over 0, we just talked about it, means there's no solution to that problem. So you're done. Okay? All right, we are almost done on the home stretch here. Write the system below as a matrix equation, then identify the coefficient matrix, the variable matrix, and the constant matrix. So you have to make sure that all the A's and the B's and the C's are on the same side of the equation and lined up. And if you do that, then you can just write across 9, -3. I would go A, B, C. We are writing the coefficients of each of these. So this is the coefficient matrix. Okay. 3, A is -3, B is 1, C is 6. Why does it do this to me? Go away. Okay. A is -5, B is 4, and C is 3. Okay. And then my variables are not X, Y, Z, so I'm not going to write X, Y, Z. I'm going to write A, B, C. And then, this, of course, is my variable matrix, because those are the variables that are in the problem. And then what are my last numbers? 8, -8, 5, and -5, which I'm sure you know are your constants in the problem. So that is our constant matrix. Okay, the next one, okay, write the system as a matrix equation. So I hope that you notice it's missing something. Okay, it doesn't have as many numbers in it, but that's because it's missing some of those variables. There's still 3 of them. I'm actually going to go up here and answer this one. So I'm going to say to myself as I work across, okay, because that's the constant. The variables are X, Y, and Z. And the numbers are 6, 4, and 0. Those are my constants. So since my X, Y, and Z, I'm going to go look at them and say, okay, what's X? There's no X in the first one. Y is 4, and Z is -9. Go to the next one. X is 3. And I'm talking about the coefficient of these things, y'all. X is 3. Y has a coefficient of -2. There is no Z. X is 5. There is no Y. And Z is -3. So this is your matrix equation that goes along with that system. Okay, these last, nope, we got 2 more. All right, so what is the solution to the system? All right, these problems, y'all, they're down here because we're making sure that you know how to write the system as a matrix before you go on. But please notice, okay, it does say solve using inverse matrices, so you cannot use substitution or elimination to work these problems, okay? We're going to do it the same way we did 23 and 24, so, which is what those numbers are. I don't know what numbers they are on your paper. My apologies again. Okay, so I think y'all know that we got X and Y, and I'm doing the inverse of the coefficient matrix. So I'm going to go ahead and write that coefficient. 6, 7, 3, -4. To the -1. Please don't forget that. And that's -12 and -6. So these are my coefficients. And it's basically set up like this, y'all, but I went ahead and moved it over because of the room that I was not very good in giving y'all. Okay? So first, to find the inverse, we did 1 over the determinant, which is -24 minus 21, which is 45. And then I switch these two, and I negate these. And I'm multiplying that by negative 12 and negative 6. I still can't figure out where I got negative 3 and 4 up there. Okay, so remember, we don't do this thing till last. And now I got to multiply these two. So that's 48 plus 42, and 48 plus 42 is 90. And then I have 36 and negative 36, which is 0. So when I distribute that scalar of negative 145 through there, okay, so this gives us, I'm going to go ahead and write it over here because this is a little different. This gives us 90 over negative 45 is negative 2, and of course 0, anything is 0. So it's negative 2, 0, but this is not a matrix. This is a system. So it starts off like that, and your answer is a point. Don't give me the matrix, please. All right, let's do this last one. Okay, so similarly, I got more room here. X and Y equals, but this is probably what you're going to do to me. 3, negative 1, negative 2, and 3. And we're going to raise it to the negative 1. And then we're going to put a 6 and a 10. Please email me if you don't know how I got that. Okay? Get that answer question before the test. Question answer before the test. Okay? So we'll go find our determinant. 1 over 9 minus 2. I should go ahead and write it like that. I'll come back to that. Switch the 3's and negate the other diagonal. Multiply by 6, 10. Okay, and so that of course gives me 1 over 7 times, oh good grief, Charlie Brown. Go away. I don't know why y'all do that to me. All right, so 18 plus 10 is 28, and 12 plus 30 is 42, and I'm so happy that those are two numbers that, seriously, those are two numbers that divide evenly by 7. So 28 divided by 7 is, of course, 4. 42 divided by 7 is 6. So my answer is 4, 6. And I was about to write a matrix. All right. Now, one thing I want to say. When you do this problem, y'all, you can put it back in there. 3 times 4 is 12, and 12 minus 6 is 6. That works. 2 times 4 is 8. Negative 8 plus 18 is 10. So I know that I have the right answer. So you can easily check that when you're going through. Okay, these last two use a calculator. And I've worked with so many people on the calculator, but let me pause 1 second and see if I can pull it up. I don't think I can pull it up on this computer. Give me 1 second. I will be right back. Okay, well, it turns out I do not have this on my computer, so I cannot actually show you the steps of putting in your calculator, but I do know that we've worked a lot in class on doing it, so if you have any trouble the night before or need to practice, you need to come see me before your test, because I will not answer any calculator questions during the test, okay? I will tell you that, you've got to get this coefficient matrix, just like we've been talking about, and find the inverse of it. And you have to write that inverse on your test to show me your work. So I will tell you that the inverse of this matrix here is to go across 8 over 5, negative 9 over 10, negative 11 over 10. If you get decimals, you need to change it to fractions. The Inspire gives you the fractions automatically. If you're on the 84, after you get your decimals, hit Math, Enter, Enter, and it will change your decimals to fractions. But don't give me decimals. It's important for you to know how to get those fractions on that calculator. Okay, so there's my second row, and then my last row is 7 over 5, negative 11 over 10, and that's a decimal, 0.5, but I want it as a fraction. Negative 9 over 10. Okay, and that is the inverse of the coefficient matrix. And then, of course, I am multiplying it by this. So what I'm doing, y'all, is, well, I'm not multiplying out, but they, on a calculator, they go ahead and multiply out that step. So that's what's happening here. And so when you multiply that out, it's going to give you a nice little pretty matrix, but we have to enter it as a point. So this one is -4, -2, and -3. And I think I saw everybody doing it in class, so I know that you're pretty much on the right track. So I'm going to give you this, and what is this one? This one didn't come out so pretty. 4/3. And now, and hold on, let me write this, and then I'll tell you what you might have done wrong if you did. 4/3, -4/3, -1, -5/6, 4/3, and 1. And then we have -1, 1, and 1. That is the inverse, and that is being multiplied by 4, 4, 2. Okay? And that answer is -2, 4, and 2. Okay? And as I said in class, every time we've done this, and on your lesson check, and in class on the review day, you must show this step to get full credit for this problem. Okay, now I just want to talk real quick about one more thing. If you messed this one up, okay, remember there's a 0 here. To x, y, there's no z, so that's a 0, and there should be a 0 for y when you first put it in to find your inverse. Okay, so that is our study guide for 2017, review of Chapter 12. And if you have any questions, please come see me or email me. Thank you very much.